All right, let's jump right in. What if everything we know, the universe, all of it, isn't made of tiny little points or vibrating strings, but is actually built from the fabric of space itself? Today we're diving into a really radical theory that suggests just that, a way to build reality, literally, from the ground up. So the person behind this idea, wow, they do not hold back. They kick things off with this incredibly bold claim, calling the construction of a single particle the most important challenge in all of physics. I mean, that really sets the stage for just how ambitious this whole thing is. And that's because we're not just talking about a little tweak to our current theories here. Oh no, the goal is way, way bigger. This is being presented as a completely new paradigm, a fundamental rethink of the very starting point for all of physics. See, the argument goes that current physics is kind of stuck, limited by the way we, as humans, see the world. So the goal here is to create something more objective, a truly fundamental baseline, a core truth about the universe that everything else can be built on. It's an attempt to find a starting point that's free of our own biases. Okay, so if you're going to build reality from scratch, you need a core ingredient, right? A basic building block. But what is it? Well, forget about matter or energy as you usually think of them. According to this theory, the ultimate ingredient is something even more fundamental, something called changing space. So, what is changing space? First off, you have to throw out the idea of space as just an empty vacuum. Instead, I want you to picture it more like cosmic clay. Yeah, a continuous, three-dimensional, and elastic material. And because it's elastic, it can be bent, it can be stretched, and, this is the key part, it can be shaped into the very building blocks of matter. And that brings us right to the heart of it all. How does this actually work? We're about to walk through the step-by-step instructions for building a fundamental particle, what's being called the fermion base, directly out of this stretchy, changing space. It's basically a two-step process. It's pretty straightforward, really. Step 1, you shape the space to give it an overall structure. Step 2, you add a specific kind of motion inside that structure. So let's break down each of those steps. Okay, step 1. It all starts with a really great analogy. I want you to imagine a flat sheet of rubber. Now, what if you sucked the air out from one spot to kind of form a balloon? You can picture that, right? That's the core idea here, taking a piece of this elastic space and pulling it into a three-dimensional ball-like shape. But the shape you end up with isn't just a simple hollow sphere. No, on the inside, the structure actually looks more like a torus, a donut shape. And it's got this perfectly clear line of symmetry running right down the middle. Now, you gotta remember that central axis because it is absolutely critical for the next step. All right, so we've got our structure. Now for step 2. This is where we take a small chunk of space inside that ball and get it spinning, continuously rotating around that central axis we just talked about. This is the move that brings motion, that brings dynamism into this particle we're building. And this rotation has a really cool effect. Because the space is elastic, remember that little spinning part on the inside, starts to drag the space around it along for the ride. It's described as being like a continuous belt trick, and it creates this constant flowing motion all the way through the particle's structure. Okay, let's just pause here for a second, because you might be asking, why are we going to all this trouble to build this specific thing? Well, it's because the goal is to build a fermion. And fermions, we're talking electrons, quarks, that kind of stuff, they are the fundamental particles that make up all the matter in the universe. Without them, nothing solid could exist. And the one thing that defines them, their most important feature, is a quantum property called spin. So there you have it. We've built this little machine entirely out of pure space. But how does this connect to the real world? This is where we connect the dots. Let's see how this two-step construction is supposed to actually copy the weird, specific behavior of a real-life particle. And here's the absolute punchline. This whole machine, this whole setup, is designed to reproduce one very specific, very strange property of a fermion, its half-integer spin. Now, this property is super weird. It has no equivalence in our everyday world, but it's what prevents two electrons from being in the same place at the same time. It's basically why matter is stable and you don't fall through the floor. So this model, with its internal spinning motion, is trying to create a physical reason for that super abstract quantum rule. Okay, let's zoom out for a second and think about the huge implications here. I mean, if this theoretical model actually works, if you really could build a self-sustaining particle just out of empty space, What would that even mean for, well, for our understanding of everything? And that forces us to ask a really profound question. What if this isn't just a clever thought experiment? What if these little structures could actually form and run all by themselves? A complete machinery that doesn't need any help from the outside. If that were true, well, the implications would be absolutely staggering. And this really is the ultimate vision here. We're not just talking about creating one particle. The idea is to create a whole new foundation for all of physics, a model built on self-operating machines that could finally explain, how we got here. A single, powerful framework to describe, explain, and just understand reality. And that leaves us with one last, truly mind-bending question. Could it be that everything we see around us, every star, every planet, every single one of us, is just the result of a huge self-operating machine? One that's built not from mysterious tiny points, but from the simple, elegant mechanics of changing space. Now that is a powerful idea to think about.